In this video, we're going to solve a problem, a beautiful problem from the topic algebra of events. So let's get started by throwing two dice. So we're going to throw two dice. Now pay close attention to the three events that I'm going to write down. The first one is event A, which says getting an even number on the first die. Next event is event B. It says getting an odd number on the first die. So whenever I get an odd number on the first die, I'll say that event B has happened. And the third one is event C, getting a sum of less than 6. Now I've given you three events, and I want you to use whatever you have understood so far in this chapter to describe the following events. Here's the list. A dash, not B, A or B, A and B, A but not C, B or C, B and C, and my favorite, A intersection B dash intersection C dash. Now pause the video. This is going to take you a while, a couple of minutes. Pause the video, think about these three events, and use whatever you have understood about algebra of events to describe these 1, 2, 3, 4, 5, 6, 7, 8, these 8 events. The rest of the video will be so much more fun if you come back after giving this a shot. All the best. Okay, so let's get started. Let's start from the beginning. Two dice are thrown. What's the first thing that we need? We need the sample space. So for the first die, we'll have these 6 events, 1, 2, 3, 4, 5, 6. For the second one, we'll also have the same set of events, 1, 2, 3, 4, 5, 6. But when both die are thrown together, we'll have something interesting. If we only threw the first die, this is what we get. 1, 2, 3, 4, 5, and 6. Now let's say we got a 1 on the second die. This is what we'll get. Let's see what this means. This first event means we get 1 on the first die and 1 on the second die. This next event means we get a 2 on the first die and 1 on the second die. The last one says we get a 6 on the first die and 1 on the second die. Now we can use the same logic to generate many more events. Suppose we didn't get 1 on the second die, we got a 2. This is what we'll get. If we get a 3, 4, 5 or 6, this is what we get. And that's all that we can get. We can get numbers from 1 to 6 on the first die, and we can get numbers from 1 to 6 on the second die. So 6 times 6 means 36. This has 36 sample points. This is your entire sample space. This is our playground. Now let's talk about the three events that we were given in the problem. The first one was getting an even number on the first die. How do we get an even number on the first die? Well, this is your sample space, and these are the numbers that you can get on the first die. There are three even numbers, 2, 4, and 6. So 2, 4, and 6 are even, and any event that has 2, 4, and 6 from the first die will be part of the event A. So this is what we have. We have these 6 events. All of them have 2 from the first die. We have these 6 more where we have 4 from the first die. And we have these last 6 where we have 6 from the first die. So these 18 events will be part of the event A. So the way to write this is event A is a set of these 18 simple events. All right, let's move to the next one. Getting an odd number on the first die. This is very similar to the event A. A had even, B had odd. So we have 3 odd numbers, which means we have these 18 events as part of event B. This is our event B. So whenever we have 1, 3 or 5 from the first die, we'll have event B. Note that we don't care what we have on the second die because we're only concerned about the first die. Anything on the second die goes, but the first die will only have 1, 3 or 5 here. All right, now let's look at event C. C says getting a sum of less than 6. So now we don't need the first or second die, we need the sum of both of them. So this is your sample space. Can you see where event C is? Think about it. 6 is a small number. If we have 1 and 1, let's start from top left. If we have 1 and 1, the sum is 2. That's less than 6. 1 and 2, that's also less than 6. That's 3. This is 1 plus 3, 4. this is 1 plus 4, 5. All of them are less than 6. What about 1 and 5? Well, if we add 1 and 5, we get 6. We don't need 6. We need numbers that are less than 6. So from the first row, we have these 4 sample points. We have these 4 events. Let's move to the next row. We have 2 and 1, that's 3. 2 and 2 is 4. 2 and 3 is 5. 2 and 4 is 6. We don't need 6. We need numbers less than 6. So these 3 are covered. Let's move to the next one. 3 and 1 is 4. 3 and 2 is 5. 3 and 3 is 6. So the first 2 are covered. There's a pattern here. For the next row, we have 4 and 1, that's 5. And the remaining numbers will give me some not less than 6, but more than 6. So only 4 and 1 is covered. And note that we don't get anything from the last 2 rows. All of these events will have a sum more than 6, either 6 or more than 6. So they're not of any use to us. So this, what you see in pink, this is your event C. So we now know what event A, B, and C look like. I think we're now ready to tackle the rest of the events. Let's take them one by one. Let's look at the first one. The first one has event A dash. A dash means the complement. This means not getting an even number. So if you have to visualize it, what we can say is the event A dash, which is in red, will have to stay out of the blue zone. Blue zone is for the event A, so we have to stay out of it, which means we'll have to take this row, and this row. So everything that you see in red on the screen will be part of event A dash. Let's move to the next one. That's event not B. So not B also means complement of B, which means everything that's outside the green zone will be part of event not B. So it's the second row, fourth row, and sixth row. Okay, so that's event not B. For the next one, we need event A, we need event B, and we need to find event A or B. So A or B means we can have anything from A or anything from B or both. Well, if you think about it, that's all we have. We have things in A or we have things in B. Think about it. You can pick anything from the screen. It will either be green or blue. It will either be part of A or be part of B, which means event A or B is the entire sample space. So all 36 elements will be part of this set event A or B. All right, let's move to the next one. For the next one, we need event A. That's our event A. We need event B. That's our event B. And we need to find event A and B. This is a bit different. And means both A and B have to happen together. And that's never going to happen. Pick anything on the screen. It will either be green or blue. It can never be both. You can never have an even and an odd number on the first die. You can either have an even number or an odd number. You can't have both, which means this is an empty set. This event will never happen. Okay. Let's move to the next one. For the next one, we need event A and we need event C. And we need to find A but not C. So A but not C means we'll start with things that are in A and we'll get rid of the things that are in C, which means we'll start with the blue zone and we'll subtract the pink zone. So this means this is covered and this is covered and this is covered. So this white zone, that is going to be our A but not C. Anything from the white zone is in A but it's not in C. So far so good. Let's take the next one. We have event B, that's the green one, and we have event C, which is the pink one, and we need B or C. So B or C means either B or C or both. So we can either be in the green zone or in the pink zone. Both of them work for us. So we can take the entire first row. We can take the second row as well because that's pink. The entire third row is covered. In the fourth row, we have this 4, 1, and we can take the entire fifth row. So basically, we've picked anything that's either pink or green or both. So that's your event B or C. Pretty neat. That for the next one, we need event B and we need event C. Okay. And we need to find B and C. So when we have an and, what we mean is we need both B and C to happen together. So we need to look at the part which is both green and pink. Well, that's the first four. And then we have these two, and that's it. This is our event. These 6 elements will be part of the event B and C. We can take an example here. For this event 3, 2, has the event B occurred, getting an odd number on the first die? Yes, the first die has the number 3, which is odd, and getting a sum of less than 6. Well, the sum is less than 6. 3 plus 2 is 5. That's less than 6. All right, let's move to the last one, and this is the most interesting part of the video. Let's see if you got this right. For this one, we need all 3 of them, A, B, and C. And what this means is, this means A and not B and not C. So A has to happen and B does not happen and C also does not happen. So let's see if we can visualize this. This is our sample space. Let's start with A. So when A happens, we're in the blue zone. Let's look at B now. When B happens, we're in this green zone, but we don't need B. We need B to not happen. So we'll have to move out of the green zone. So when we move out of the green zone, lucky for us, we're back in the blue zone. So this is event not B. This is also event A. Let's look at event C. This is our event C, but we also don't need event C. We need event C to not happen. So we have to move out of the pink zone. We need event not C. That's the gray zone. So everything that's not pink will be event not C. And we don't need pink. We don't need event C. And I think we are ready now. We need event A, we need event not B, and we need event not C. So everything that's blue and everything that's gray, that's going to be covered. That's going to be our event A intersection B dash intersection C dash. So that's going to be these 3 elements. That's going to be these 5 elements, and that's going to be the last 6 elements. So this is the list. You can check your answer as well. And I think with this, we have a pretty solid understanding of algebra of events.